Hi dear students. So let's see this question that was asked in KVPY 2020 SX Part 2, one of the most beautiful questions in whole KVPY 2020 SX paper. So basically here what is happening, we have to imagine a situation where the free magnetic charge exists. What does this mean? This means that we know that in our world we have not yet found a North Pole and South Pole in isolation, whereas we always find protons and electrons, they can occur freely in isolation. That means the existence of protons does not require electron to be present, and existence of electron does not require proton to be present. They do not occur, like they may not always occur in pair, whereas North Pole and South Pole always occur in pair. We can never find an North Pole in isolation or South Pole in isolation. But here the question is saying that imagine that free magnetic charges can exist. That means free North Pole or South Pole can exist. Okay, now we have a U-shaped wire. Okay, and a rod of length L, which is length L, is being pulled with constant velocity V. Okay, and here we have electric field which is going perpendicular to the screen. It's not given whether the electric field is going inside the screen or coming outside the screen. Okay, but it's present in this situation, and like in the whole screen it is present electric field, and it is going inside. It is not given whether it is going inside or outside, but it's perpendicular to the plane of the screen. So you would have seen such situations in the motional EMF where a magnetic field is actually present, and when we pull this rod, then an EMF is induced, and there are certain things that can be asked कि current की value क्या है, power develop कितना हुआ है, so different things can be asked, right? So but here electric field is present. Okay, and we have to find the value of the magnetic EMF and the direction. Okay, that means whether it will be clockwise or anti-clockwise. तो direction की बात करनी है and magnetic EMF की बात करनी है, right? So basically what is electric EMF, what is induced electric EMF? So you know this is the value of electric EMF. Okay, now similarly on the similar pattern we can say that how we will define magnetic EMF. So integral B dot dl will be equals to magnetic EMF. Okay, so we have to find the magnetic EMF in this loop. So we have to find the value of integral B dot dl in this loop. Okay, this will be equals to magnetic EMF, right? Now using Ampere's law, magnetic EMF will be equals to mu naught into current. Okay, by using Ampere's law we can say that this will be equals to mu naught into current. Okay, however, if you have read the topic of electromagnetic waves, there is a topic in that displacement current. Okay, so James Clerk Maxwell, he said that the integral B dot dl is equals to mu naught I if the flux of electric field is constant. That means if the flux of electric field is not changing, then we can say that integral B dot dl will be equals to mu naught I. However, if the flux of electric field is also changing within a loop, then integral B dot dl will be equals to mu naught I plus this will be, sorry yaar, sorry, I'll have to draw that again, my bad. So let me quickly draw this. So this is being pulled with velocity V. Okay, and electric field is E. Okay, so I was saying B dot dl, this is the magnetic EMF. This will be equals to mu naught into I is the conduction current. That means the current due to the flow of the protons, or we can say electrons rather. Okay, current due to the flow of the electrons plus the rate of change of electric flux, which is epsilon naught d phi E by dt. Okay, actually this d phi E by dt is the change of flux. Epsilon naught will have to be multiplied. So this was the law given by the James Clerk Maxwell. Actually, James Clerk Maxwell had generalized the Ampere's law. So James Clerk Maxwell said that if there is a change of electric flux happening within loop, within any loop, so the integration of B dot dl will be equals to mu naught I plus epsilon naught into d phi E by dt. What is this d phi E by dt? Rate of change of electric flux inside this loop, right? So now, if you, so we can say that this I will be zero. Why this I will be zero? Because I is actually the current, that is normal current, which we know, which is flow of the positive charges. Okay, here there is no such charge flowing. Here the charges which are flowing is magnetic charges, not the electric charges. Remember, so we can say that this part I will be zero. Okay, now what is d phi E by dt? So again, d phi E by dt is Similarly we can write EVL. Okay, just like in the case of motional EMF, you write d phi b by dt as BVL. Okay, B is the magnetic field, V is the velocity, and L is the length. So similarly, what will be the change of electric flux? EVL, right? So this will be EVL. So we can say that this integration of B dot dl will come out to be mu naught epsilon naught EVL. This is the value of magnetic EMF induced. Okay. Now mu naught epsilon naught we all know is 1 upon c square. So this will become EVL upon c square. Okay. Now comes the direction part. How will it be induced? In what direction it will be present? Okay. So we will require the direction of electric field, which is not given in the question. So it is not possible to comment whether this EVL by c square, which is magnetic EMF induced, with whether it will be clockwise or anti-clockwise. It is not possible to comment. But suppose the electric field was coming outside. Okay, then we can find that if you keep your thumb outside, then you can see that if electric field was coming outside, then the magnetic field would have been induced in the, then that the magnetic EMF would have been in the anti-clockwise direction. Okay, in that case, so we can say that uh, if if electric field was coming outside, then d phi e by dt would have been positive. Okay, the flux would have been increasing. Okay, and it would have been increasing, electric field coming outside and increasing with time. So in that case, d phi e by dt would have been positive. Then in that case, this LHS will also be positive, and we can say that magnetic field will be induced in the anti-clockwise direction. Okay, and opposite vice versa will also be true. But since the direction of the electric field is not given, so we will not be able to comment in the direction. Okay, so possible option could have been C as well as D in this scenario. Okay, I hope you would have understood the situation. That's it. Thank you.